So we've been talking about data and how to present data. And so far the conversation has been around sort of univariate statistics. I have a variable and I'm trying to sort of communicate to you what's happening in that variable. But oftentimes the things that we're interested in communicating are about how variables fit together, about the patterns that exist and trying to communicate those patterns effectively. And so today we're going to talk about one strategy that gets used a lot and is quite effective, or can be used effectively, I should say. And that is cross tabulations, or crosstabs, or two-way tables, or just tables if you're not a statistician and you want to talk about what's actually happening. So these are ways of presenting particularly categorical variables in a way that is easy to be able to identify sort of the tallies within different subcategories and how they fit together, or to present sort of percentage information. I'll just walk you through some tables, right? So this is a table that I use. I believe it's General Social Science Survey data from 2018, asking if people can be trusted. So it's a categorical variable. There's three possible responses, and we're sort of breaking that out in our crosstab, two-way table, or just table in terms of gender, sex, male, female. And so what you can see pretty quickly is that we have all the possible combinations. Those 6 combinations are available to us. We also have totals for the columns. We have totals for the rows. So I can look and see that, almost 1,300 people said that you can trust people. I can look and see that there were about 1,750 men in my sample and almost 2,200 women in my sample, and nearly 4,000 people total, right? I've got the total number of cases as well. And all this information is being presented as frequencies. And that can be useful. However, oftentimes, because things are not balanced in a nice way, it's easier to read and interpret the information when it's presented as percentages. And so here we have percentages that are organized across rows. So we're looking for the marginal distribution of men or gender or sex. And so if I'm looking at that first row of male, it tallies to 100 at the end. And so what I'm saying is conditional upon looking at men. So I'm only looking at men. This is the distribution of how people say that you can trust. So 34.8% say you can trust, and 60.5% say you cannot trust. And then conditional on looking at women, the female row, I can say what percent trust and what percent don't trust among women. And I can look at that and say, well, among women, it looks like 64.2% say you cannot trust. Women seem to be slightly less trusting of people than men. Okay, so I can find that information and pull it up fairly quickly using the row percentages when I couldn't necessarily see that easily looking at the overall percent or the overall frequency counts. I can also organize my percentages as column percentages. And so if I'm interested in the distribution of people who say you can trust, I could say, wow, 52.4% of the people in my sample who said you can trust were women. And that might seem to contradict sort of what I had said earlier, that women were slightly less trusting, but it's because there's more women in our sample. We can actually see that in the column total at the end. 44.5% of our sample was men and 55.5% were women. And so maybe I can use that to kind of interpret what's happening with those column percentages conditional on saying, you can trust, you can't trust. So is it better to use row percentages versus column percentages? It seems like we're more easily able to grab information this way. It really depends. And it really depends on the story that you're trying to tell, the story that is interesting to your audience. And so just having the full range. But I'll even go a step further in terms of sort of encouraging you to think about how you work with your data. And this is something that was advice passed on to me by Robert Gross, who was a historian who wrote a very famous book that was data intensive called The Minutemen and Their World. And I was working with Bob as his research assistant. And one day he said, Brian, I'm going to tell you the secret that I used in writing The Minutemen and Their World. And I got like really excited. And I kind of leaned in. I was like, Bob, what is this secret? And he said, I would present a table, and then I would talk about the table using different measures than what I presented in the table. I was like, oh, Bob, that is not a secret. That does not seem that amazing. until I started looking at how people actually work with tables. And far, far too often, what happens with tables is that people organize their table and they plunk it into their text and they say, refer to table 4. And the assumption is that the reader is going to break from reading and go and study that table and figure out what the important pattern is. And so what Bob's insight is that if you're presenting a table on with frequency counts, like that first one that I showed you, then as you're talking about the table in the text, and you should talk about the table in the text, talk about it in terms of percentages. Talk about the row percentages and how they break down, and communicate what's important and interesting about that table to your reader using that other sort of way of presenting that data. And if you present row percentages to your reader in your table, then as you're explaining that table and talking about it, give them the frequency counts. Tell them there were 4,000 people in this survey. Tell them that it was predominantly, or not, I shouldn't say predominantly, it was disproportionately women versus men. Tell them with the frequencies how many men responded can trust in that survey. And so that's the sort of secret to being able to make your writing about tables, I don't want to say engaging, because writing about data is difficult to do in an engaging way, but at least to make sure that you are presenting the full story about what's happening in your data in a way that your audience will be able to sort of understand what you think is important in that table. Okay, so I'm going to pivot a little bit from that and talk a little bit more about patterns and what we're looking for when we think about patterns in our data. And so one thing that we're maybe interested in is a pattern actually real? Does it exist? Is it something that could just look like there's a pattern because I'm squinting really hard and looking for something? Does it exist because I drew my sample and samples are kind of random and they bounce around and fluctuate, and I just happen to draw a sample that was a little bit odd? Do I know if the pattern I'm seeing is just the oddness of random sampling variation, or if it's something real? This is something this gets at the idea of statistical significance, and we'll talk about hypothesis testing and statistical significance later on. But for now, I'll just simply say statisticians have figured out a way to be able to tell us if a pattern is likely to be random sampling variation or is likely to be a sign that there's something more meaningful going on in our data. Maybe we're interested in the strength of our pattern, right? How closely do two variables move together? Is it something where it just seems to be a slight difference, or is it something where it's like, wow, this is a really powerful pattern that's explaining a lot and really driving the outcome in my data? I'm interested potentially in the direction of the data, and we'll talk about positive relationships versus negative relationships or something else. And then maybe I also want to, as part of that, have a conversation about, is the relationship linear? We could talk about linear as monotonic, it's sort of consistent, or is it curvilinear, or is it something else? This ends up becoming more important when we'll talk about regression. It's maybe less important when we're talking about tables, although that I'm not actually sure that that's true. Okay, so I'm going to briefly highlight this idea of a positive relationship versus a negative relationship. Because in tables, it's a little bit reversed. If you're thinking about sort of a scatter plot that you might have worked with in high school algebra, and you learn the equation for a slope, rise over run, you learn that positive relationships sort of start in the bottom left and they sort of drift to the upper right, and negative relationships start in the sort of upper right and they drift to the lower left. And so if you think about it, it's like you're increasing positively on your x-axis, and you're increasing positively on your y-axis, and that's a positive relationship. Where a negative relationship is you are increasing positively on your x-axis, but you are decreasing. You have a negative relationship or a negative effect on your y-axis, and so a positive divided by a negative is going to be a negative number. It's a negative relationship. In tables, it gets completely reversed because we're not looking at sort of that first quadrant of sort of our XY plane. Instead, what happens is our categories are oftentimes, labeled 1, 2, 3, 4. And when computer programs sort of go to build in our categories, they will put sort of 1 for the first column, 2 for the second column, 3 for the third column, but then 1 for the first row, 2 for the second row, 3 for the third row. And so actually it's sort of the flip flop of what we have when we think about scatter plots. And so as a result, This is a positive relationship in a table, even though it's has that sort of start at the upper left-hand side and go to the lower right-hand side as you read across, which normally we would associate with a negative relationship. The reason for that has to do with the flip-flop of scatter plots versus tables. At any rate, this is an example of I guess, a perfect positive relationship in a table, right? So ask the question, do you approve of the president's job performance? And the president, Joe Biden, currently prompts conservatives to say bad and liberals to say good, and maybe moderates are indifferent. And so we can say, oh, look at that pattern. It's nice and neat. But I should flag another thing in talking about patterns with tables is that a lot of times with our categorical variables, they're not objectively linked to numbers, right? The decision to make conservative the value 1, moderate the value 2, and liberal the value 3 is an arbitrary decision, right? I mean, there's sort of an ordering there, but I can order it a different way. I can make liberal 1 and moderate 2 and conservative 3. And the story is still the same. There's still a strong linear pattern there, but now it's a negative relationship, at least in tables. And I haven't changed anything about the data other than how I've labeled my categories. And so I want to kind of flag this very briefly because when we're talking about negative relationships versus positive relationships, it's not like these things are set in stone. These things are a function of how we create and code our data. And so that's worth acknowledging and recognizing. But I'm also sort of showing these tables because I want to show a third thing that can happen. You can have a situation where the president is viewed as doing very well by moderates, but liberals and conservatives are both feeling upset and say bad job on that. And so in this situation, we would look at it and we'd say, well, there's not a linear pattern. It's not a positive pattern like we saw before. It's not a negative pattern like we saw before. And it might be tempting to say, particularly if you're relying upon some statistical measures that analyze tables and tell you what the patterns are, that look for linear patterns, you might say, well, there's nothing there. But if you actually look at your table and look at how the data is distributed, it's very clear that a pattern does exist. And so I'm highlighting this as encouragement that you should always look at and scrutinize your data as a table or as a scatter plot, depending upon the kind of data that you have, because you may see things that are going to be missed by statistical measures that are assuming that there's a linear relationship, that there's a linear pattern. And that is a common pattern that frequently is helpful, but it doesn't show up in every, but there are situations where that's not the case. And using tables, using scatter plots are the way that we catch that and find that and identify that.